I'm using the app Zoom right now to do some notes for section 6.2 and to kind of show you a little bit more of how Zoom works. Guys, I recommend this. Use Zoom. I can help you so much more with the homework or with anything to math through Zoom. We can have up to about as many as 100 people. Hope to do some live classes this way. So I'm going to share my screen with you so you can see what I see, and I'm going to teach you 6.2. Another wonderful thing about this program is that we can annotate, meaning we can write, draw, type, erase, highlight, whichever. What you need, let me change colors here. In your notes is this, okay? You need to write these definitions, these words down. These are very important to use. When 3 or more lines, now remember a line has 2 arrows, okay? Array has just 1 arrow on the side and it's got a point here. So sometimes like when they had a line that went all, or an array that starts here and it goes out and has an arrow, and then it says like find the external angle. Sometimes you'll see that. And a segment, you already know what a segment is. Goes 1 point to another point. These are all segments. These are all segments. You don't see any little arrows, okay? So when you have 3 or more of those intersect in the same point, they are called concurrent. All of those lines, this one, this one, this one, this one, this one, they all come in to that point. That means all those lines are concurrent. And the point of intersection of the lines, rays, or segments is called the point of concurrency. Okay, now circumcenter in a triangle, the 3 perpendicular bisectors. So remember, perpendicular bisector is where a line intersects another line at a 90-degree angle. All right, so you have this one, DP, EP, and FP. Well, they label in PDP, EPF, so it doesn't matter. Those lines are all forming right angles. Okay, these are perpendicular bisectors. All right. The point of concurrency is the circumcenter. This right there, P, point P, that's the circumcenter. Okay. So this theorem here, the circumcenter of a triangle is equidistant from the vertices of the triangle, meaning it is the same distance. P, point P, is the same distance from B, C, and A. This line is the same length as this line, which is the same length as this one. I should say segment. Those 3 segments are all equidistant, same length. If PB is 4, then the other ones are also 4. Only if the you have where only that point where the perpendicular bisectors meet, okay? Not just any lines, okay? Perpendicular bisector. I forgot to mention one point. Bisector means it cuts the line into 2 equal halves, okay? That was probably something I should have shared earlier, sorry. So you know perpendicular means it cuts at a 90-degree angle, but you also need to know bisector means it's cutting this line in half. So this is congruent with this one, okay? This, maybe I'll try my finger here. 1, 2, 3, is congruent with that one. And then 1, 2, 3, 4, 1, 2, 3, 4. Those are congruent to each other because these perpendicular bisectors cut in half at a right angle, and where they meet is called the circumcenter. which is going to be the same distance from all three vertices, those angles, okay? Put that in your notes. And I'm just gonna scroll down here really quick to show you. Oh, I need this. Okay, let me clear all the notations here. This is a proof just to prove that theorem. You can look at that one. I'm not gonna ask you to put that in your notes though. On the next page, it's got example 1. Very useful. I won't do this problem for you, but if you click tutorial right there, so let me get the mouse, and I click on that, it's going to take you to the video. I mean, there are videos for all of these already, so I'll just play it
A
for
carnival
seconds.
operator wants to locate a food stand so that it is the same distance from the carousel C, the Ferris wheel F, and the bumper cars B. Find the location of the food stand S.
Okay, and they're also available in Spanish. They're all in Spanish. So I won't do this problem, but my book has some extras, and those are the ones that I will make videos on the whiteboard. All right. The monitoring progress, you do need to put in your notes. I want you to try them and put them in your notes. Every time you see monitoring progress, okay? Don't worry about the construction. Example 2, again, watch the tutorial, do the monitoring progress. All right. I will do some examples on the board in other videos, but I want you to be able to do that much. This way you guys will definitely learn the material. In the homework, don't just guess and hope you get the right answer. If you do that, you're going to fail the quiz, you're going to fail the test, you're not going to learn anything. When you get to the final, you're going to fail. You're not developing the brain. You're just going to fall further and further behind, okay? So I'm going to stop the video here and do some examples, and then I'm going to come back and do another video on Zoom teaching you the next theorem, okay? So I'm going to stop sharing and I'm going to stop recording.